Probability theory is the study of chance or likelihood of events happening. You can go from one extreme where it's not going to happen to the other extreme where it's certain to happen. For instance, what's the chance that it's going to rain in the desert? Or what's the chance that the sun will set tonight? Probability is looking at everything from the impossible, 0% like the desert, to 100% like the sun setting every night, and everything in between. Will Michael Jordan make the shot? Now, mathematicians and statisticians love to study chance so that they can predict the future. But how accurate are they? For instance, if I roll a 6-sided dice 60 times, if you had a mathematician in front of me, he would say that the number 1 would be rolled 10 times, the number 2 would be rolled 10 times, the number 3, 4, 5, and 6 would all be rolled 10 times. But let's see, let's do it for ourselves and roll the dice 60 times and see what happens. That's 10, 20, 30 times we've rolled the dice. Oh, it looks like 2, 3, and 4 are about tied. Now we've got 40 times. We're up to 50. And one more roll. We're up to 60 rolls. So the computer did 10 rolls for every one spin. And as we notice, when we look at this, the number 1 only happened 5 times. But why is that so? There was 6 numbers on the dice, meaning we all had one out of 6 chance of getting the number 1, or 1 out of 6 chance of getting the 3, or 1 out of 6 chance of getting the 4. So if we rolled it 60 times, and there was 1 out of 6 chance of getting the 1, for instance, then we would get 1 out of 6 times 60 equals 10. But we didn't get that. We got 5. Was the mathematician wrong? Tomorrow, when you come to class, we will be looking at the differences between experimental versus theoretical probability. In theory, we should have got the roll of 1 10 times, but in the experiment, it only happened 5 times. When we look at experimental and theoretical probability, we'll be losing a lot of key terms. Some I have down below. They are random experiment, an occurrence whose result is uncertain. So like my dice, we didn't know whether a 1 or a 2 or a 3 was going to come up, or how many times the number 1 would come up. When we rolled the dice, we didn't know what number would come. B, number of trials. Well, we rolled the dice 60 times, so that would be the number of trials. Outcomes. For our outcomes, we had the option of 1, 2, 3, 4, 5, 6. Those were the possible results of the experiment. D, frequency. Well, how many times did we see the number 1? We saw it 5 times. That was the frequency for number 1. E, relative frequency. Well, that's how many times did we see the number 1 out of how many rolls did we have? So that would be 5 out of 60. F, sample space. That's all the possible results when we rolled the dice, which was 1, 2, 3, 4, 5, and 6. And G, event, which is any subset of the sample space. Tomorrow, when you come in, we're going to do an experiment to see what experimental probability is all about and how fun probability is.